This is the third day that we're on radicals. I want to walk through all the major concepts we've gone through so far. I do apologize. The handout I gave you had some typos, a little bit of errors, but not much of a difference of what you see up here on the screen. So the first thing you need to know is that when you're taking the square root of a non-perfect square number, you need to rewrite it with multiplication to get a perfect square number, all right? Even before that, you need to know how to make a perfect square number list. So the square root of 20 is not a perfect square number. You rewrite it with multiplication to get a perfect square number, in this case, the number 4. The next important thing that you need to know is the key concept that when you have two terms that are being multiplied inside a radical, you could take that radical and split it to each of the terms and have multiplication between them. We should all be comfortable with that because when we have the square root of 20, it's not a perfect square number. We rewrite it with multiplication to get a perfect square number. Now, because of the above key concept, we're able to split the root, and we could do the square root of 4, and the square root of 5 stays the same. So the square root of 4 is 2, and the square root of 5 stays the same. So the answer is 2 square root of 5. It says you could also use this rule backwards. Okay. Example, the square root of 2, you can't really do anything with the square root of 2. The square root of 32 you could simplify, but if you think about going backwards, instead of having this split going backwards and putting it together, if I put these together, it'll say 2 times 32, which is 64, and the square root of 64 is 8. So that is another way you could apply this key concept. Not only that, I guess I forgot to put it in this worksheet, so maybe somewhere on the side on this one, it's a good idea to remember that this rule with multiplication also applies with division. So the square root of A divided by B, that could also be split to the square root of A over the square root of B. Anyway, guys, let's continue with number 3 right here. Now, I know your numbers got messed up. I don't even think there's a number on this one. But it says right here, when you multiply a square root value with itself, the square root disappears and you get just the inside value. So when I have the square root of 3 times the square root of 3, yeah, we could use the rule to put them together and we'll get the square root of 9, but that takes us back to 3. So if you just memorize this rule, you don't have to actually show this work. Whenever you take the square root of something and multiply it by that same square root of that value, it'll be just the value inside of the root. So if I have the square root of 17 times the square root of 17, what's my answer going to be, guys? 17. No more square root. That's the rule, guys. When you apply a square root value with the exact same square root value, the square roots eliminate, and you just have the inside value 17. I hope that makes sense to everybody. Let's go back. Number 4, which I don't even think yours is numbered 4, I'm sorry. When you have a number outside of the radical, simplify the radical first, then multiply the outside values. So right here I have a 5 on the outside of the square root of 18. So I'm not going to worry about the 5 right now. I'm going to worry about the 18. 18 is not a perfect square number, so I need to rewrite it with multiplication to get a perfect square number. So obviously I'm not going to do 6 times 3, that neither of those are perfect squares. I want to do 9 times 2. That way when I split the roots, I'll have the square root of 9 and the square root of 2. That way the square root of 9 gives me 3, and the square root of 2 stays the square root of 2. Now, I did forget to put the final answer here, so I apologize. Right now, please, let's write down equals, what's our final answer when I have 5 times 3 times square root of 2? 15 square root of 2. So let's put all on our paper, 15 square root of 2. That's our final answer for that example. I'm sorry about that typo. Okay, another important fact that we should know already is that the square root of a negative 1 is really imaginary, the variable I. Anytime you have a negative inside a square root, it's just going to become I. Okay, so right here, any negative on the inside of a square root, it's going to become I. So right here you have negative 9. You're taking the square root of negative 9. So we all know that the square root of 9 is 3, but that negative sign is going to be an I. So it really becomes 3I. Now the complete work here is negative 9 is really negative 1 times 9, and the square root of negative 1 is I, and I times the square root of 9, which is 3. I times 3 is 3I. You don't have to show all that work. All you need to do is know that when you have the square root of negative 16, what's your answer going to be?
4i.
4i. That's it. Right? That's all you need to know. If I have the square root of negative 25, what's the answer? 5i. That's all you need to know. Okay? So, moving on. Number 6. You can multiply numbers with numbers and radicals with radicals. So right here, you really have, let me zoom in even further. We have 4 times the square root of 3 times 3 times the square root of 2. It's all multiplication, even between the 4 and the square root and between the 3 and the square root. It's all multiplication. So when you have pure multiplication, commutative property of multiplication allows you to rearrange things. So I'm going to put the 4 and the 3 together. There it is, 4 and 3. And then I'm going to put the square root of 3 times the square root of 2 together. There it is, square root of 3 times square root of 2. So we all know that the answer of 4 times 3 is what? 12. There it is. And when you multiply the square root of 3 times square root of 2, that's going to be a square root of 6. So your final answer is 12 square root of 6. Now, is there anything else you could do? The answer here is no. But if you would have ended up with like an 8 right here, then you could break it down to 4 times 2. If you would have ended up with the 12, you could break it down to 4 times 3. But 6, you can't break it down. You leave it like that. So those are all the things that you should already know and be able to apply. If you know all that stuff and are able to apply all that stuff, how about you show me by doing this class opener right now? I'm going to pause it. You guys try it, and then I'll go through the explanation of each. Number 1, the square root of 40. 40 is not a perfect square number, right? You want a perfect square number. So let's rewrite it with multiplication to get a perfect square number. So you're not going to do 5 times 8 because 5 is not a perfect square. 8 is not a perfect square. What are you going to change 40 to? You need a perfect square number. 4 times 10. So if you break it down to 4, 4 is a perfect square times 10. 10's not, but who cares? When you split it, you're going to end up with 2 because the square root of 4 is 2, no more square root. And the square root of 10 is going to stay the square root of 10. And that's it. That's your answer. Now, if you start thinking, oh, wait a minute, but 10, I could go 5 times 2, but neither of those are perfect square numbers, so that'd be pointless. So that is your answer, 2 square root of 10. All right, I'm just going to keep going here. Number 2, what do you know about this negative sign? It's imaginary. So how about this? Whenever you see a negative in there, you could right off the bat, you could just put an I on the outside, and you could just rewrite it as 20, no more negative. If you want. You don't have to, but you could do that right off the bat, or you could wait till the end. But anyway, the negative inside the root becomes an I on the outside. And now let's deal with 20. Am I going to rewrite it as 2 times 10? No, why not? None of those are perfect squares. All right, so what am I going to break it down to? 4 times 5. So 4 times 5, and I'm going to split the root, split it. I'm going to end up with an I out in the front and a nice, beautiful number 2, and the square root of 5 stays the square root of 5. So what I really have here is a letter times a number, right? If you had x times 2, would you say x2 or would you say 2x? 2x. So right here, we're going to write it 2i. And then the square root of 5, you just bring it down. You can't do anything with that. That is your final answer. Moving on. Number 3. Everybody should tell me the answer to that just by looking at it. What's the answer? 14. Because this really says 7 times the square root of 4. And everybody should know that the square root of 4 is really 2. So what it really says is 7 times 2, which equals 14. If you got it wrong, it's okay. Just make sure you understand that. Whenever you have a square root, try to simplify it. And then worry about the rest. Number 4. We had written down, it wasn't typed up, but we had written down that we could split this root. So let's do that. Let's split it. Square root of 16 up on top. Square root of 25 on the bottom. These are perfect square numbers. This is a really easy answer. What's the answer? 4 over 5. So the answer is 4/5. 4 over 5. Let's jump to number 5. One of the rules above, or one of the truths above that we had, says we could rearrange things, right? So how about this? What would I rearrange? The 2 and the 3 I want to put together. 2 times 3. And then this square root of 3 and this square root of 3, I want to put them together. Times square root of 3 times square root of 3. So you can rearrange it. And 2 times 3, that's 6. And we should all know from the other truth above that when you multiply a radical with the same exact value, the radical disappears, the square root disappears, you end up with just 3. So what you really have is 6 times 3. So your final answer is 18. 6 times 3 is 18. Let's move on to number 6. Let's rearrange things. I want to put the integer -2 times the integer -5. And then I want to put the radical square root of 2 times the radical square root of 8. Now right here it's not the same exact radical, so I can't just erase the square root. But when I put both of these together, when I use that key concept above backwards, remember we usually split them apart. Right here, let's put them together. And when we put them together, we're going to end up with the 2 times 8. And what's 2 times 8? So you really have the square root of 16, and that is beautiful because that's a nice, beautiful answer. What? 4. Okay, so let me not get ahead of myself. Let me bring down the this answer. What's -2 times -5? Positive 10. So I have 10 times the square root of 16. That's really going to be 10 times 4. So my final answer is what? 40. That was a fun class opener. Oh no, there's still more. Yes. Rearrange. Let's write the numbers first. -3 times 3. And then let's write the radicals next. The square root of 2 times the square root of 6 times the square root of 3 negative, right? So -3. So we could easily, everybody understands how I rearranged it, right? Okay, now let's do, what is -3 times 3? -9. And now the radicals, I want to actually put all of these together and see what happens, right? So when I go 2 times 6 times -3, what's 2 times 6?
12.
What's 12 times -3? So I really have -36 in here with a multiplication of -9 on the outside. So what is the square root of -36? 6i, right? So you really have 6i. So you have -9 multiplied by 6i. That's like saying -9 times 6x. -54i is the correct final answer. -54 with an I.
When you do the I, does the I have to be like a circle or could it be a dot?
It could be a dot.
I thought you always did it that for a reason.
I do that because I'm weird. All right, how about number 8? What do I do? Break it down, simplify. So we're going to split the root to each one. So the square root of 20 over the square root of 4. And the square root of 20, I could rewrite that as 2 times 10?
Yes.
No.
Why?
2 is not a perfect square. 10 is not a perfect square.
4 times 5.
4 times 5. 4 times 5. And we're going to split the root. And the square root of 4 is what? 2. And the square root of 5 stays the square root of 5. So this is really what belongs up here on top. So I'm going to rewrite it as 2 square root of 5 instead of the square root of 20, right? And on the bottom, I have the square root of 4, but what's the square root of 4? 2. Now on my answer, I have a 2 on top and a 2 on the bottom. What could I do with those?
1.
They cancel out to be 1. So my final answer is really square root of 5. Now, this is a, do you understand? Do you understand that problem? That's great. You need to understand that skill. But is there a quicker way? Yes. Look at this. What does it say?
20 divided by 4.
And what's 20 divided by 4?
5. But what about the square root?
Well, yeah, exactly. What about the square? So 20 divided by 4 is 5. So you'd have the square root of 5. That's your answer. Okay. So that doesn't happen all the time. It just happened this time, right? But you do need to understand all that process that we did. Okay, so that was a class opener with a huge review of what we've done already. There's more to do. So, continued on simplifying radicals. You cannot leave a radical in the denominator. You cannot do it, all right? You cannot leave a radical in the denominator. Check this out. When you have a radical in the denominator, you're going to have to get rid of it. How? by multiplying both top and bottom by that square root value. So imagine we had this problem, the square root of 9 over 20. Yeah, you split the root to the top, you split the root to the bottom. And on top, you could do a square root of 9, which is 3. And on the bottom, the 20 becomes 4 times 5. And then you split that root, and it becomes a square root of 4 times square root of 5, which is really 2 square root of 5. Everybody understands that, right? Now, with this new detail, that you cannot leave a radical in the denominator, you have to get rid of this square root of 5. And that's why on this example, it says right here, now we must get rid of that square root of 5. So here's a square root of 5, and how do I get rid of that square root of 5? I multiply it with the exact square root value, which is square root of 5, and you do both top and bottom. Okay? That's what it says up here, guys. You must get rid of it by multiplying both top and bottom by that same square root value. So right here, to get rid of the square root of 5, I need to multiply both top and bottom by the square root of 5. Because when I multiply the square root of 5 times the square root of 5, what's that answer? It's just 5. So I'm really going to have, check out the work over here. The square root of 5 times square root of 5 is just 5. So I really have 2 times 5. So my final answer right there is 3 square root of 5 over 10. Okay? So this was all one problem. This problem has all of this work. Here's the final answer, 3 square root of 5 over 10. Again, the main idea here is you cannot have a radical in the denominator. You could have it in the numerator, but you can't have it in the denominator. So let's do some more examples. Number 1, what do I need to do to get rid of that radical? What do I need to do to get rid of that radical? Square root of 3. Multiply both top and bottom by that same square root of 3. So everybody do this. Square root of 3 on the bottom, square root of 3 on the top. Multiply both. On top, 2 times the square root of 3 is exactly that. 2 times square root of 3. Yes? Yes. On the bottom, square root of 3 times square root of 3, it's just 3. That's it. Is there anything else? I mean, you're supposed to check. Could I do anything with this square root of 3? No. Could I reduce 2/3? No. So yeah, that is the answer right there. That's your answer.
And if you did have to reduce, you just cancel out and put the 3 by itself.
Right. Let's take a look at number 2. How do I get rid of that square root of 2 on the bottom? Multiply both top and bottom by the square root of 2. Square root of 2. So up on top, I will have 12 times the square root of 2. You just write it over. And on the bottom, you have what? Just 2. No more square root. And now you could simplify 12 divided by 2. 12 over 2 is 6, right? So you could just simply cancel 12 and 2 and get a 6 up on top. So your final answer for number 2 is 6 square root of 2. That's your final answer for number 2.
Wait, so the bottom's always going to be the same number, right? You don't really have to do the work for that?
The bottom, you always have to get rid of the radical. And yeah, it's going to just be the same number that's inside your root. Let's take a look at number 3 here. Now, there's many roads to the same place here. You could, right off the bat, start multiplying both top and bottom by the square root of 8. Or you could simplify it and make it a little more simple. So let's simplify the square root of 8. Let me do that right here on the side. The square root of 8 breaks down to 4 times 2, right? And if I split the root, I will get 2 square root of 2, right? So how about this? Let me just rewrite the whole problem. 3 up on top with a 2 square root of 2 on the bottom. Now, I still need to get rid of the radical. And what is the radical part? It's the square root of 2. So I need to multiply both top and bottom by that same radical value. Square root of 2. Right? So this 2 out here, I don't worry about it. That's just a nice number. But this square root of 2, I need to get rid of it. So I'm going to multiply by the square root of 2. Now think about this, guys. This 2 right here, it's just going to be a 2 out in front. And the square root of 2 times the square root of 2, what does that become? That becomes 2. So you really have a 2 times 2 down there. And up on top, you have the 3 times the square root of 2. So what's our final answer going to be? 3 square root of 2 over 4. And there's nothing else to do, nothing else to reduce. That's your answer on number 3. Let's move on to number 4. we could get rid of the square root of 20 by multiplying both top and bottom by the square root of 20, or we could simplify it first and just get rid of the radical. Let's break it down to 4 and 5. Okay, so right here, I want to change the 20 to a 4 times 5. I'm going to split the root. That way it becomes 2 square root of 5. So I'm going to rewrite this whole thing right now. I have an 8 up on top, but instead of the square root of 20, I'm going to rewrite it as 2 square root of 5. Now, at this point, I could reduce 8 divided by 2, or I could wait and do it later. It's totally up to you guys. You guys want to reduce right now? Okay, so 8 divided by 2 is 4. So how about this? Let's put a line through the 8, put a line through the 2, and put a 4 left over up on top. Okay, now I still need to get rid of that square root of 5. So what do? Multiply both top and bottom by that same square root of 5 value. So up on top, I have a 4 with the square root of 5. Now let me write that. Up on top, I have 4 square root of 5. And on the bottom, I have, there's no more 2, but I have a square root of 5 times square root of 5. So what do I get right there? I get 5. No more square root. And that's your answer. 4 square root of 5 over 5. Let's take a look at number 5 here. You can't do anything to it, so let's get rid of it. So what do? Times square root of 3 times square root of 3, both top and bottom. Up on top, I get 6 times square root of 3. That's what it stays like. On the bottom, I get what? 3. So your final answer is
6 times square root.
6 divided by 3 is 2. Final answer is 2 square root of 3. No more fraction.
Wait, so you can never simplify like you do on the other side?
You could always reduce.
No, but inside the...
Number 7, let's split that root. We're going to have the square root of 81 over the square root of 18. What's the square root of 81?
9.
Square root of 18 I cannot do, but I could break it down, right? 6 times 3?
Yeah.
No, not 6 times 3.
No.
9 times 2. So 9 times 2 is what you want. 18 is not a perfect square number, but 9 is. That way when you split it, you could actually do the square root of 9, which is 3. And of course, you still have the square root of 2. So that's your answer, right? No? It's not your answer yet. You have to multiply both top and bottom by that square root of 2 value. So up on top, you'll have 9 square roots of 2 over 3 times 2, because the square root of 2 times square root of 2 is just 2. So at this point, I could multiply 3 times 2 and get 6. And I might as well do that. I want to have the answer 9 square root of 2 over 6, but we could reduce 9 over 6. You could reduce by 3, and you'll get 3 up on top and 2 on the bottom. So the final answer is 3 square root of 2 over 2. That's your final answer for that question. Number 7. Are we done? I wish. There's still more to learn. Okay, guys, please wake up. Very important. Our final fact of the day. Listen up. A square root is really the power of 1/2.
So if you have 2 square roots, you have 1.
What?
I guess that does make sense. If you have 2 square roots, you end up with a 1. Now, check this out. The square root of 9. A square root is really the power of 1/2. So instead of the square root of 9, I want to say 9 to the 1/2 power. Because the square root is really the power of 1/2. And instead of 9 to the 1/2 power, I'm going to rewrite 9 as 3 squared, because I know that 3 squared is 9. And then I could apply that rule of exponents that says, when you have a power to a power, what do? Power to a power, what do? Multiply. What is 2 times half? 2 times half is 1. 3 to the 1. What's half of 2? 2 times half is 1. So 3 to the 1 is your answer. Now, why the heck would you want to do it this way when you already know that the square root of 9 is 3? We do it this way because it comes in handy when you have radicals that have variables. So check out example 1 right here. If you have the square root of x to the 8th power. You're really going to rewrite this square root as the power of 1/2. So you have x to the 8th to the power of 1/2. When you have a power to a power, what do? You multiply. What's 8 times half? What's half of 8? 4. That's why your answer is x to the 4th. It's a very easy concept.
Is that another way to do it? Or?
No, this is something new you need to know. So check this out. The square root of x to the 12th is x to the 6th. The square root of x to the 20th
10.
is x to the 10.
So we just split in half pretty much.
So it just gets cut in half pretty much, right?
There's something that won't work.
Why is that? Because the square root is really the power of 1/2. Okay? So you need to know that. Now, what about when you have something like the square root of x to the
7.
5th? Then you can't really cut that in half nicely. So let me show you the work that you're going to have to do right here. You're going to have to actually rewrite it as x to the 4th, because that works out great, cutting it in half, times x to the 1. And you're going to split the root. And now you know that half of 4 is 2, and the square root of x to the 1, that's just the square root of x. You can't do it. You leave it. So that would be your answer to the square root of x to the 5th. Let's go back over here and look at the example. Example 2, we have the square root of x to the 7th. Now, if it were the square root of x to the 8th, the answer would be x to the 4th. Nice and easy. But it's x to the 7th, so you're going to have to rewrite that as x to the 6th times x to the 1. That way, when you split them, you could actually do the square root of x to the 6th. That becomes x to the 6th to the 1/2, which is really just half of 6, which is really x to the 3rd. And the square root of x, it just comes down. So there's your answer. X to the 3rd times square root of x. Let's look at the most complicated example. We have the square root of 4 times x to the 3rd times y to the 6th. By the way, guys, you need to know how to do this. The calculator can't do variables. Okay? So you guys were all excited because you could simplify square roots when it was just numbers, but we have variables. Calculator can't do that. So right here, we're going to split that square root to the 4, to the x to the 3rd, and to the y to the 6th. So you split that root to all of those. And then after that, you could actually do the square root of 4. You'll get 2. And the square root of 3rd, x to the 3rd, since you can't divide by 2, we're going to split it to something that you could divide by 2. So you're going to say x to the 2nd times 1. That's really x to the 3rd. But when we split it, now you could take this to the power of 1/2, which means that half of that's just going to be 1 regular x. The square root of x just comes down. And over here, the square root of y to the 6th, we know that that's just y to the 3rd. You don't even have to show all this work. So half of 6 is 3. I mean, here's the work that you need to show, that you could show if you wanted to, but I already know that half of 6 is 3. So our final answer is going to be 2 times x times y to the 3rd and the radical at the very end. 2x y to the 3rd, radical x, square root of x at the very end. That was a long lesson. It's a long video, but we need to know all of this stuff. So knowing all of this stuff, you should be able to do this homework right here. Now this first worksheet is just with numbers, so everybody should be good with that. But the second one is dealing with numbers and variables, right? So what we just covered, let's take a look at which one's easy to do. Number 11 is easy to do. Somebody should be able to look at this and give me the answer. 9 A D to the 2nd. 9a d to the 2nd, right? Just by looking at it. Why? Because every single item in the square root right there works out perfectly. Check it out. When you split the root, remember, the square root of 81 is just 9. The square root of a squared, that's like saying a squared to the 1/2 power. So it's just like dividing it by 2, so you just get a. And the square root of d to the 4th, that's like d to the 4th to the power of 1/2. So again, it's like dividing the 4 by 2, and you get d to the 2nd. So really easy stuff, right? On the test, if you have this question, you really don't even need to show any work. You should just be able to get the answer. Of course, if you do show this work, I appreciate it. It proves that you know what you're doing. Now, not all of them are that easy. Like, look at number 13. That one's pretty interesting.
25 times 30.
Let's first start by, on this one you do need to show your work. Let's split up everything. The square root of 75, the square root of m to the 5th, and the square root of p squared. So which one's the easiest one to do?
P squared.
The p squared. What's the square root of p squared?
P.
Just p. Right? Okay, so that's going to be part of our answer. But now let's work on the rest. Well, 75, it's not a perfect square number. You're going to rewrite it as 25 times 3. That way, when you split the root, you will get 5 square root of 3, which is really saying 5 times the square root of 3. And now this other middle term right here, the square root of m to the 5th, that's kind of interesting. It's not divisible by 2. So what you want to do is break it up to m to the 4th times m, right? Because m to the 4th, I'll even put m to the 1. M to the 4th times m to the 1, that's really m to the 5th. So all you're doing is rewriting that m to the 5th. And when you split it, now you could do the square root of m to the 4th. What's the square root of m to the 4th? M to the 2nd. And how about the square root of m? You can't do it, you just leave it, the square root of m. So you have all of these things that you're multiplying. 5 times the square root of 3 times m squared times the square root of m times p. You want to put the radicals at the end and the numbers and letters at the beginning. So I'm going to have a 5 first, and then I'm going to have an m squared, and then I'm going to have the p. And then at the end, I'm going to have the square root of 3 times the square root of m. But then again, I could actually multiply those radical values and put them together. So I could have 5 m squared p square root of 3m. So that would be my final answer on number 13. Like I said, that one's a lot funner, more fun than the previous one. So good luck on doing this. The answers are on the back. Oh yeah, by the way, we are not doing the last 4. 21, 22, 23, 24, don't do them. I haven't shown you how to do them, so I don't want you to do them. Good luck.